Hi everyone, good morning. My name is Vincent Branger, so you can say Vincent Branger, it's not an issue for me. I'm French. I will try to articulate as much as possible because I know I have a horrible accent. I apologize for that. I'm a senior consultant in France, and I'm working to help my customer in their virtualization projects, especially desktop virtualization. And the last 2 years, I had a lot of projects with WAN optimization, and I made a lot of studies about Branch Repeater, Riverbed, Cisco, and so on, and I want to share this information with you. But before to begin, I added one slide this morning after the Geek Out show. I'm not sure if everyone was here. Is that, just in case, okay, if you need it, is a famous OSI model with all the layers we saw yesterday in the last question of the Geek Out show. We will need it a little bit because it's really a network session today. So, another slide I just added is, you can see all the session in video, and I really recommended to use this session from Jo Harder about also Citrix networking. She really explains how ICA is working actually, and it's really interesting. And I think both sessions together can be really great for you, I hope so. It's really a must-see in this BriForum. So, a small content precision, because at the beginning for the call for papers, I made a proposal about Branch Repeater and other WAN accelerators for desktop virtualization. And during the session announcement, Brian and Gabe said, Vincent, if you are listening to us, please take some notes, okay? So I'm very serious, so I took some notes. We don't want you to focus on Branch Repeater only. We want you to focus on WAN acceleration products in general. That's why the session today is really about WAN accelerators, not only Branch Repeater, but also Riverbed, Cisco, and so on. And the idea is to see how they work, how they can help in desktop virtualization area, and when to use them. When, with some measurement, we can decide to use them and we have to use them. So, we will make a small introduction about why we need some accelerator or some improvement on WAN. And we will analyze 3 parts of improvement of WAN networking. The first one is all the TCP optimization we can have. For example, the famous TCP window. And then all the compression and deduplication algorithm. And in third, all the QoS, the quality of service. And we will, of course, analyze ICA, RDP, and PC over IP. And then I will finish with 2 user cases, one with Riverbed, one with Citrix Branch Repeater. Okay? So, here is a typical architecture with desktop virtualization. You have an headquarter here with a lot of servers, all centralized in a data center, I would say. Perhaps with internet access, with an access gateway, for example. And here, some branch offices accessing to the data center with typical remote desktop protocols such as ICA, RDP, and so on. So it's really typical nowadays. And the common analysis I can see a lot in, by a lot of system integrators or sometimes customers. Before they said, oh, okay, it's very easy to calculate the bandwidths we need, and all is about bandwidth in this common analysis. Let's say you can take 20 kilobit per second as a common answer. You multiply by the number of users, and okay, you know your bandwidth. Unfortunately, we know all that it doesn't work like that. Because we don't know if it is an average, a maximum. It's very difficult to know. And what about printing? Because of course, you cannot print with that. Okay, so this 20 kilobit per second is really, so I wanted to say stupid, but it's very simplistic, okay? And now the problem is, we don't have to connect to a specific application, like a published application. We want to access to a full desktop. And with a full desktop, a full Windows desktop, we cannot control what the user will do with this application. Let's say he will use Internet Explorer. We cannot control on which website he will go with Flash, video, audio, and so on. And I see now in some request for proposal or some documents, a new answer is 100 kilobit per second. And I think it's also stupid as 20, because we don't know. And the real answer is a typical IT answer, I agree, but it depends. It depends on the apps, and it depends on the user and the way they are using the apps. Okay? So it's really difficult to have an analysis only based on the bandwidth and on this kind of number, or value. Furthermore, it's very difficult to manage some items on a farm level because a farm is, by definition, several servers altogether. And for example, we cannot control the TCP flow control at a farm level. It's not possible. We cannot control the congestion on the WAN network. It's also impossible. It's very difficult to have some data deduplication. Perhaps we can have some data deduplication on each server, but it's not good enough on the farm level. And finally, we have also some difficulty to manage traffic shaping or quality of service. We can do some prioritization, for example, at the farm level. Okay, it's possible at the server level. But it's not good enough also for one environment with a lot of branch offices with different kind of bandwidth available for each branch office. So I want to take a very simple example to analyze this famous TCP window. Perhaps you all know what it is, but just in case. The default size of flow control window for TCP is 64 kilobytes. Okay? So let's take an example of one link from 1 gigabit per second and 20 millisecond latency. What happens exactly? So t equals 0, I send some data. But after 0.5 milliseconds, that is my end of window, because I can send only 64 kilobytes, okay? I have to stop to send my data, okay? Then, after 20 milliseconds of latency, data arrived in London here, and acknowledges are sent to the sender, okay? So, okay, data arrive and acknowledge are sent. You need the same time to get back your acknowledge, and after 40 milliseconds, acknowledge are effectively actually received and new data can be sent again. What's happened in terms of efficiency? If we calculate the efficiency is about 1%. That is the actual throughput, that is the window size divided by the round trip time, that is 40 milliseconds. It's only about 13 megabits per second. So you have a 1 gigabit link, but you can use effectively actually only about 13, okay? And that's, of course, very difficult to manage that. So that's the first point, this famous TCP window. Congestion. Congestion is a very important point in one environment. So I saw it's funny, with networking, we always used some picture with roads and cars. It's easier to understand sometimes. So the problem is how to keep a fast sender from swamping a slow receiver with data, okay? And the main principle of TCP is the flow control. And the feedback is sent from the receiver to the sender. But sometimes, because the network is oversubscribed by a lot of computers, by a lot of senders, there is too much traffic and there is congestion, exactly like here on the road, okay? And what happens if there is congestion? Packets can be dropped, and then user experience can be affected. And when user experience is affected, that is that, okay? I'm sorry, I've only found photo with women, but I'm sure there is also a lot of one with men. So, a typical fault solution I have seen many times in my career is, can additional network capacity eliminates congestion? You have a 2 megabyte bandwidth, or I have some issues with the network, I double it. Okay, let's go for 4. I still have some issues. Let's go for 8. And it doesn't work. It simply doesn't work, because increasing the network capacity is not enough to have sometimes a better response, especially for us because we have real-time protocol. I forgot to say that, but RDP, ICA, PCoIP are real-time protocols. They are affected very quickly, the user experience. So I found a very interesting sentence here explaining why it doesn't work. Because if you increase the network capacity, you just decrease the number of times you have a congested network. That's all. You don't really solve the main issue of congestion, okay? And here the sentence is for voice over internet protocol or online gaming application, but it applies completely to remote desktop protocol such as ICA, RDP, and PCoIP. That's a very interesting picture. Here is a congested network with 1 second sample, okay? And as you can see here, if you analyze this kind of figure, you can say, oh, I don't have any congestion on my network, okay? But if you look closer, for example, only 0.25 second sample, you can see it's completely different. And if you look more, closer, here, you can see that, oh, sometimes I have congestion, because here it's an average. And your network provider gives you only this kind of information with an average. And the time here given by your network provider is normally very high. So you cannot see if there is sometimes congested network. If we are looking at the packet level here, we can see that very often the network is congested. It's exactly the same, just we look closer and closer here, okay? And here we are at the packet level, so we can see that at the packet level there is some congestion. That's very important. So don't trust, I will say, your network provider when you see such graphics. We all know that we just talk about bandwidth, but perhaps more important is latency. Latency, user experience is very, very sensitive to latency. And this latency or delay is the time it takes for a packet of data to get from one point to another point. So normally it's only on one way, the latency. But very often, people, when they are using the word latency, it's actually round trip time latency that is on one way and back to the sender. Okay, so be careful with that because it can be sometimes difficult to understand. So when you do a ping, for example, it's you can measure the latency, but it's the round trip time latency. But all people say latency. Okay. Another thing very, very important and can be a real nightmare for a network administrator is the jitter. The jitter is a variation in the latency and the delay or packet arrival times. Here you can see a wonderful example of jitter. Here, the jitter is very low because the latency in average here is almost the same. But here we can see that it's completely different because of some network congestion, surely. And here we can see we have a big jitter and affecting the user in a very important way in terms of user experience. Okay. So we saw the bandwidth, we saw the latency and jitter, that is completely related. And now the third one is the problem of loss of packets. There is two main reasons to lose packets on a one network. The first one is a congestion. If there is congestion, the buffer of the routers can be full, and when they are full, if a new packet arrives, it's simply dropped. Okay? Then packets are lost. That's the first reason. The next one, it can be transmission bit errors because of a low quality of the link in a particular segment of the link, for example. That's another reason. That's completely different. The typical solution are to retransmit the packets by the transport layer, that is by TCP. Okay? But the actual algorithm without any optimization are not so good because they are really waiting for to understand that they have lost actually a packet, and then they need a lot of time to retransmit. Okay? And they cannot manage the TCP window very well because they decrease this TCP window before to re-increase it. Okay? So it affects very, very hardly the performances of the network. And if packets are lost, retransmission involves, of course, bandwidth limitation by definition. Just an example, so let's do some math. I didn't do the demonstration here, so it's taken from a scientific publication. But here is a very good formula to calculate the actual throughput relating to the percent of lost packets. So let's take a simple example with a round trip time of 200 milliseconds and only I would say 0.25% of loss. If you do the math, your throughput is less than 1.2 megabit per second. So even if you have a network with 4 megabit per second, if you have 0.25% of loss, you can go quicker than that. Okay? So it's really interesting to see that because it's completely related, and this formula can be used very often. So now, when can we use WAN accelerators? Or when have we to do something on our WAN environment? Here are some common values to determine that. If we have we will have network congestion if our network usage is constantly about 30%. Okay? Just because of the graphic I show you with the time to analyze the congestion. If latency is above 75 milliseconds, user experience can be affected. So the latency, so the RTT about twice, okay? If jitter is above 50 milliseconds, user experience can be affected. And if packet loss is above 0.25%, user experience can be affected. If you are in one of these cases, you can really think about WAN accelerators or at least WAN optimizations. Quality of service. 4 issues must be addressed regarding quality of service. What are the application needs for the network? How to regulate all the traffic entering the network? How to reserve resources at routers to guarantee performances, like shaping, for example, and whether the network can safely accept more traffic. That's the main point. So, we did for now the theory about WAN issues. Let's go now to the WAN accelerators actually. So here is a magic quadrant in 2009 for WAN optimization. We can see here as the leader Riverbed, Bluecoat, and Expand, and Citrix here and Cisco here just in the visionaries and challengers square. 1 year later, we can see that, so Expand, I'm sure you know that, is not anymore here. And Riverbed is always in the leader, and Ipanema goes on to the visionary. And 1 year later, in January 2012, we can see that Silverpeak is really now entering in the leader square with Bluecoat. Citrix is almost in, and of course for us we will analyze it. And Cisco is still in the challenger square. So my idea here was to analyze these 3, Riverbed, Silverpeak, and Bluecoat, because they are in the leader squares, plus Citrix, of course, because of ICA optimization, logical for my presentation about desktop virtualization. And I added Cisco because of the agreement between Cisco and Citrix last year. So, at a glance, we can see here in this table the 5 companies I will analyze, so with the inception date. The WAN optimization here, we can see that Riverbed and Silverpeak are really pure player. They have been funded only to work in this area. Bluecoat, Citrix, and Cisco made it by acquisition. In 2006 with Orbital Data for Citrix, and in 2004 with Actona Technology for Cisco. Okay? Almost all have either physical appliance or virtual appliance. Okay? And sometimes we can use also a client for mobile, so for laptop, for example. And this client can play the role of a branch accelerator with, of course, not all the feature. And we can see here that Silverpeak is the only one with no client-side software. And I talked with them recently, and they simply don't want to have one, okay? Because they say that they are really data center WAN optimizer, and they don't want to have a client-side. Okay, that can be important for us because it would be good to have some mobile capability when we are talking about desktop virtualization. So that's not a very good point for Silverpeak here. So we will analyze all these products with ICA, RDP, and PC over IP. But before optimizing any flow of data, we have to do some things. First of all, optimization can be done if and only if flow is not encrypted. Because if it is encrypted, we don't know what is inside, and we can't do anything in terms of algorithm or something like that. That's a very important point, because on one end, we can perhaps use it because it's automatically configured, or on the other end, it must be manual. And if it is manual, the problem is it's often for all the users, even if they are connecting from LAN. So it can be really an issue. Second one, the optimization in terms of compression is optimal if and only if the flow is not really compressed by another mechanism. Because it's very difficult to compress an already compressed by another algorithm flow, okay? So ideally, I would like to have an unencrypted flow and uncompressed. However, the aspect with non-encryption is not an issue because the flow can be re-encrypted between the two appliances. So let's have a look with our products and with each protocol. With ICA, since Riverbed OS 7.02, it's automatic for basic and advanced encryption. Okay? That is, if there is a connection from an ICA receiver to Citrix server across a Riverbed, Riverbed can see that it is an ICA protocol and can ask to the server to disable the encryption and the compression automatically. You don't have to do anything, and it will be only for this flow. Okay? The novelty is about here the advanced encryption, because before it was only with the basic encryption before this version of Riverbed OS. Of course, this mechanism from Riverbed is not supported by Citrix. That's very important to know. If you have some constraints like Sarbanes layer or something like that, it can be an issue. Silverpeak, impossible to do that automatically, so you have to do it manually. The same applies for Blue Coat. So, of course, with Citrix Branch Repeater, no problem. They can manage it, fortunately, I would say. And with Cisco, with this agreement I already talked about, it's also automatically and supported by Citrix. Okay? So the two only one supported by Citrix are, of course, Citrix itself and Cisco because of this agreement. Riverbed is also automatic, but not supported by Citrix. Regarding RDP, for all the appliances, it's only manual. Okay? And you can deactivate, disable encryption and compression only with Windows 2008 R2. Okay? It wasn't possible before. And with PC over IP, it's simply impossible there is no way to disable encryption. Okay, it's simply impossible. So, of course, it will be very, very, very difficult to optimize PC over IP over the WAN. So, let's go now to the TCP optimization we can have with such accelerators. So, as you may know, there are a lot of requests for comments, RFC, regarding TCP and TCP optimization. Some one are very, very simple. For example, here, for TCP designer, I don't know how to pronounce that in English, 2 square, I don't know, so 32 was equal to the infinite, okay? So the problem is, with 32-bit sequence number, for 1 gigabit, for example, per second network, it's 34 seconds. And the packet lifetime of the internet is 2 minutes. Okay? So here we can see we have some issues with that. So with the RFC, we have an extension of the second number to avoid this kind of problem. And we use simply the TCP header. So that's just one example. There are a lot, and I will talk just about this one because I think it's the most important. You know, it's my former example with my actual throughput because of the inefficiency, I will say. And when you are using this, the same RFC, you can really optimize that. And there is here an interesting measure called the bandwidth delay product. Okay? You take your bandwidth, you take your latency, in RTT, so your round trip time delay, and you just multiply it. Here you have a value corresponding to 100% of efficiency on your network. Okay, so that's a very useful measurement. If we do it for our example here, so 40 milliseconds is the RTT and 1 gigabit. We have 40 million of bits. So when we calculate the window size must be 5 megabytes to have this 100% efficiency. And this RFC is able to manage window size up to 1 gigabyte. So with this very simple example, if we can implement this RFC between one branch office and the data center, we can use 100% of our network in this case, for example. Okay? You see, that's very important. The other issue we talked about was the congestion. And the problem is, when there is congestion, here we can have a completely uncontrolled network, and as we have seen, we can have a very, very bad bandwidth and performances on the one network. With the non-RFC, there are a lot. I have a list just after. We don't go into deep detail. We can control here the network. And here there is an interesting word, is good put. Good put compared to throughput. So good put is really the rate at which useful packets are delivered. Okay? So here in green, it's the good put available on this network, for example, because we have to control the congestion. Okay? Yeah, congestion collapse and control. So here are a list, I'm sure it's not exhaustive, of all the RFC used to manage this kind of issues. I think the most interesting one is the selective acknowledgements, because when you have some congestion and when packets are dropped, you need a long time to retransmit your packets. And here you have a lot of mechanism to have a fast retransmission of packet in order to have a better good put. okay? And here, for example, is the case of Riverbed. Riverbed are using what they call, so here is the case without any optimization, okay? You send, and then up, you have to stop, you send again, stop, because of congested network. And with algorithm as a mixed TCP or high-speed TCP, you can have really a very good retransmission, and all these algorithms are based on a fast retransmit algorithm. And as you can see here, you can really manage much better your congested network, okay, with this algorithm. So every vendors of one optimizer are really doing the same thing. They are using common RFCs. Sometimes they are changing some things, but it's very, very little. And here is the case of Riverbed, but Silverpeak has exactly the same with selective acknowledgement, window scanning, high-speed TCP, and so on. I won't go into details. It's just to show you that they have this TCP optimization. And the same is applies for Blue Coat, for example, with high-speed TCP also, and scalable TCP, and selective acknowledgement. And also the same with Branch Repeater, and also the same with Cisco. Okay, with Cisco, they call that TCP flow optimization, TFO. Okay, and that's exactly the same as the other. So we cannot really compare the WAN accelerator regarding our problematic of desktop virtualization, because really they apply the same RFC when we compare them. There is something here very interesting between Silverpeak and Riverbed. Silverpeak is very, very proud to use a forward error correction. And they are very proud to say that if you have a network with a lot of loss because of low quality bandwidth link, their algorithm will be wonderful to manage that and to avoid any retransmission. Okay? The idea is very simple because it's based on a very, very known algorithm. Every n packets, a special packet is sent with a parity system. So if any of the n packets is wrong, as an error is detected, with the last packet, we can rebuild the packet. Okay? So that's interesting, and they use also a packet order correction in case there is a lot of way to go from one point to another point. And they said they are the only one to do that. And Riverbed said, it's not so good. It seems to be good, but it's not so good. Why? At Riverbed, we are using selective acknowledgement, and we can control the order with a specific value Q equal to packet order. Okay? And what the Riverbed say is FEC is ineffective for network congestion because of consecutive drop packets. That is, here, as I said, every n packets, one additional packet is sent. If one of these packets, just one, is lost or is wrong, you can rebuild it without any retransmission. That's good. But in case of congestion, you don't have only one packet, usually. You have more than one packet. And then you cannot rebuild anything. You have to retransmit anyway. Okay? So to be honest, I agree with Riverbed in this case regarding our problematic for desktop virtualization. Silverpeak has a very interesting algorithm, but I think it's not useful for us for desktop virtualization. And as Riverbed say, avoiding network congestion is more effective and doesn't add control bits. So if there is no control bits added, we have a better good put, okay, as I defined it. So it's my opinion, okay. Okay, now after this TCP optimization, so as I said, when we compare all the products, it's almost the same, except for this point of FEC from Silverpeak that is different from the other one. Now let's talk about compression and deduplication. Riverbed has a really interesting algorithm to do that. When a request is done by the client side, a file, so here the animation is with a file, but it's exactly the same for the other thing. The file is completely analyzed, indexed, and we are looking for any ability to deduplicate data. Okay? Then data are sent to the network, copied to the other into the other appliance, and with the same, of course, indexation and deduplication. And then in this appliance, the file and the data are completely rebuilt. The next time we will send the same file or the same part of the file, like, for example, I don't know, a signature in Outlook, the end of a document or the beginning of a document or of any document, it won't be retransmitted because it will be already here. Okay? So it's very interesting. For us, regarding desktop virtualization, it can be also very, very good because we know that we send a lot of bitmap, and the bitmap can be really the same between several users because they are using the same application, for example. So what we do, for example, at the client side with, for example, bitmap caching with ICA, we can do it for all the users all together here in the appliance. Okay? So that's interesting. With Silverpeak, it's completely different because, I didn't say, but Riverbed works on the TCP level. Okay? Silverpeak is the only one to work on the IP level, so level 3 of the OSI model. And there is a real-time deduplication at IP level, and what they say, it's completely application independent. Of course it is, because it's IP packet. Okay, so they don't know what there is inside. Okay, they just have some optimization for CIFS, just that. But for ICA RDP, it's impossible. And they say that, so when I say it's impossible, so there is no specific optimization for this algorithm, okay, for these protocols. So they can do deduplication with RDP, with this ICA, if it is unencrypted and uncompressed. And here the question mark for PC over IP is, okay, PC over IP is a UDP protocol. So with Silverpeak, we can optimize PC over IP because it's on the IP level. But eventually, we cannot because it cannot be unencrypted. Okay, so be careful with that because it's very important. Blue Coat. Blue Coat has some mechanism with byte caching, so it's not so interesting, and compression, but it's a common compression for any protocols, and there is no specific optimization for ICA, RDP, or PC over IP. So it's really, we have really nothing here with Blue Coat. Branch Repeater. So Branch Repeater, of course, we have some optimization with ICA. And I speak, of course, here only with ICA. There is nothing specific for RDP and, of course, nothing for PC over IP, as you can imagine. So here, we have a cross-session compression. So between all the sessions crossing the appliance. You just have to build what they call a service class policy based on an IP range or punch range. And you just have to enable acceleration and compression. What is interesting here is they have an adaptive compression. They can see that in ICA, you are, for example, printing. Okay, you are printing inside ICA, so I can use one algorithm specific to the fact that you are printing. If it's real-time human interface design, you have another algorithm, and so on. If it's a USB transfer, you have another compression algorithm. Okay, so that's interesting. This adaptive compression according the type of the flow, and you have also caching, and some deduplication also algorithm, but not in the same way of Riverbed. Cisco, as you may know, had signed an agreement with Citrix last year. I think it was in October or November. And they made an announcement in February of this year. And just a few days ago, they announced the Cisco WAS 451 as a new product all. So I'm not aware with Cisco terminology, so I have a look on that. New product all is not synonym for release date. Okay, so it's not officially released. If you want it, you have to ask for it to Cisco, and they could give you the product if you want to test it. Okay. However, very often the official release date happens a few months later. Okay. So there is no multi-stream support yet. We will talk about that later. Here, I copy and paste the information about optimization. And as you can see, the core WAN optimization technology to ICA are TCP flow optimization, as we saw, and Cisco context-aware data redundancy elimination. So I had a look into that, and it's really deduplication and compression of the flow. So that's very interesting. I have some customers using it for other protocols, and they are very happy with that. So I think it can be really good. So of course, we don't have any feedback from now of this technology. I just know one company in Germany using a beta version of WAS with ICA, and they're very happy with it. Okay, but I can just say that regarding that. So, last topic is quality of service. Quality of service. So, for Silverpeak, we have nothing specific because it's working on an IP level, so it's not possible anyway. Blue Coat, nothing also specific for our protocols. Riverbed, we will have a look in Riverbed because they have a Citrix plugin. So they have something specific for Citrix to optimize the ICA protocol. But they have nothing specific for RDP and PC over IP. Citrix, so guess, of course, they have. And Cisco, of course, they have too, because of this agreement. But as you have perhaps read, there is nothing about QoS. Okay? Specifically to ICA, I mean. You can have some deduplication and compression technique, TCP optimization, but nothing about quality of service. And they don't support yet the multi-stream ICA. They will. They already announced they will, but not for the moment. So, Riverbed. By default, if you put a Riverbed appliance and you have an ICA flow, it won't be optimized because it's disabled by default. Okay, it's a pass-through. To optimize ICA traffic, it's really obvious. You have to choose first the queue, that is packet order. It's mandatory, of course, for ICA. And MSTCP only if you have a very high packet loss, okay, because of the ROS transmission algorithm. Then you have to choose the class. So there are several classes here, real-time, interactive, business critical, normal, etc. And the recommendation from Riverbed for ICA is real-time or interactive. You put ICA on interactive, that is the second one, if only if you have already a protocol more important as voice over IP, for example, in real time. You don't want to have the same for both protocols here. You have to select deduplication and compression in memory because, as you know, ICA is a lot of small patterns and very, very small packets. So it's very interesting to do it directly in memory. And then you can apply a traffic shaping for your ICA traffic. Okay? So usually you put your appliance, you define all that, but you don't define the shaping, and you just have a look how you need actually for each branch office, and several days or weeks later you can configure the traffic shaping. And there is some prioritization inside the ICA traffic. If we are looking inside ICA with Riverbed, it is based on the priority packet tagging. At the beginning, it was defined already for MetraFrame, and it has been, of course, redefined with the multi-stream. And here you have the 4 values: high priority, medium, low, and background. And here you have the description of the virtual channels that are used for each one. I think, yes, I have put on the slide, you will have that, all the virtual channel and the, when there is a single stream and when there is multi-stream. Okay, you have here the new definition. So here it's just a summary. And as you can see here it's taken from an interface of the administration console from Riverbed. You have exactly the same. So you can apply prioritization between that. For example, I had a customer using ICA with a very simple application, but what they need really was to print 2 pages very, very quickly. Okay? And by default, host print traffic is a background priority. And for this customer, we put, with Riverbed, printing for this branch office in a higher priority to optimize the printing traffic. You know, so it can be really useful, and it's impossible to do that, for example, with Silverpeak, Bluecoat, and so on. So it's really interesting. And here also, they have a specific algorithm to better compress and to better cache all client drive mapping. Okay, CDM is for client drive mapping. You just have to put it here and enable, and you will see that it's a client drive mapping flow, and it will optimize it specifically. Okay, so you have a lot of feature inside Riverbed, inside the ICA. Of course, the main problem we have with Riverbed is the fact that it's not supported by Citrix. All these optimizations are not supported by Citrix. So if you have any issue, any problem with that, it's impossible to talk with Citrix to have some information or to have some support. Okay, so that's really a big issue. Riverbed and PC over IP. So that's quite funny, because PC over IP, as I told you, is a UDP protocol. So only the session establishment and control is based on TCP, but the content is based on UDP. If you read the VMware View 5 PC over IP guide, they say it's already highly compressed, okay, doesn't need and cannot make use of WAN accelerator network devices. So that's clear, okay? And some WAN acceleration features are built into PC over IP, use of UDP, okay? No resending of tail drop packets, and audio and human interface device are already the highest priority packets. But if we saw what I show you with TCP optimization and so on, it's not enough. It's simply not enough. So this argument is not good enough for me to have better performances. Okay? And we all know that PC over IP is not so good on one environment, even if it's better since the last version. What Riverbed said? Riverbed said, oh, since our 7th version of Riverbed OS, UDP is optimized. Okay, we have a buffer, we take the flow, and then we decided to stop, we indexed, we deduplicate, we compress, and yoo-hoo. That's good. Why not? But it is possible to use it with PC over IP? Not at all, because the flow cannot be unencrypted. Okay? And if you use the Riverbed website and you type PC over IP, you have just one link, and the link is from more than 1 year, and said, we will do something with PC over IP. Yeah, we will do, but nothing for the moment. Okay? And I think it will be very difficult because of this inability to disable encryption. So even if they say we can optimize UDP, it cannot be used for PC over IP. Yeah.
Earlier you said that the average for the old rate for ICA was 20, and then the new rate is somewhere around 100. But we know that that's kind of just conjecture. What is the PC over IP rate? What is the number?
So as I told you, I don't like to use this number because they are false for me, okay? But I don't have any number for PC over IP, but a lot of people are saying that if you are using video, audio, and so on, you have to count to 1 megabit, okay? So it's a lot for one, okay? Because, you know, it's really interesting because with HDX, with PC over IP, and so on, you can really have really interesting algorithm to optimize your traffic, but at least there is more traffic because you are using video, you are using audio, and so on. So it's exactly what Brian said yesterday, comparing, bandwidth, CPU, and user experience. Even if you have better bandwidth and better CPU, the user wants a better user experience. Branch repeater. Branch repeater, you can prioritize ICA traffic based on different categories. The first one is the desktop group name, for example, desktop, publish application name, or ICA priority tag, exactly as we have seen. Just a small note regarding publish application name. It's only available for the initial application. If you launch, for example, I don't know, Outlook first, you will have this prioritization of Outlook. If you launch, for example, SAP, perhaps more important than Outlook, because of the session sharing, it will use exactly the same optimization and prioritization than Outlook. To have really a specific optimization for SAP, in this case, you have to disable session sharing. But to be honest, disabling session sharing is worse than have this optimization. So this optimization of prioritization based on publishing application name is not actually possible to use it. Support of ICA multistream. Branch repeater is the only WAN accelerator able for the moment to use ICA multistream. Okay? It's impossible with Riverbed. I think it will be because it's not so difficult to manage just for TCP ports, additional TCP ports. And Cisco will add it for sure because it's already written and it's a part of the agreement with Citrix, so it's sure. And they have, as I already said, the adaptive compression according the flow inside ICA. So let's go to two user cases I had this year. One is in progress. The number one, so it's a building and civil engineering works company in France. They have 600 users in 45 branch offices. Some are very, very small, with 1 to 3 users in ADSL, and 2 are larger with SDSL, 1 to 2 megabit. The problem is with this company, they want to centralize, and they would like to use desktop virtualization for every users. However, we have a small issue here. We have some AutoCAD users. And of course, with 3D or 2D, and even if there is some improvement in HDX and so on, it's really difficult to use it with such bandwidth. Okay, so currently they have one server. It's completely distributed, so they have one server or more per office. So, and the aim was to centralize. So what we'll do this summer is to have a POC, so with XenApp, with SIM client for the task workers, and FAT client for AutoCAD users. We are thinking about using, what is the name of this REST product, you know, to have reverse seamless, VPX, I think so, VPX, to have reverse seamless. So one desktop session, remote desktop session, and with AutoCAD installed locally, oh, sorry. And here, when we did when we did the first studies, we saw that ICA was really good with Riverbed, and that AutoCAD was really amazing with Riverbed. Okay, that wasn't the case with Branch Repeater. And Branch Repeater was a little bit better for ICA, but was really not so good for AutoCAD. Okay, so for large branch offices, we will use a still-head appliance. Okay, so full Riverbed technology. And for small offices, because they have only 1 to 3 users, we cannot put a complete appliance. It's too expensive, simply. We can use the still-head mobile with repurposed PCs. Okay, so it's I think it's a good trade-off. Okay, we are currently doing the POC with one site, so with 2 sites, one big, one small, and it works really well. And so I talk, of course, about the fact that Citrix is not supported this kind of solution, but the customer is aware of that and decided to go with Riverbed. So user case 2, so it's in healthcare, also in France, with 400 users, 23 branch offices, all are with 2 megabits per second, only one is with 1 megabit per second. And there are some power users, like developers, marketing, and so on, but it's only in the headquarters, so we don't have any issue with this user. It's really only task worker doing a simple application, so it's really an easy case. And the problem is sometimes, even for small offices, branch offices, you can add up to 15 additional users because it's a training center, okay? So you have to deal with that. And we work with desktop virtualization with usual repartition, distribution between XenApp and XenDesktop. And the 5% of XenDesktop are for the developers, marketing, and so on. And it's 100% ICA for branch offices. And in this case, it's really logical to use Branch Repeater because of the licensing model, because it's 100% ICA, and so on. Okay, and it works really good. It's already deployed since June, and it works fine. Yeah.
Then you mentioned the bandwidth of 1 to 2 Mbps. Is that shared by all users?
Yes, yes, it is.
And is that typically what you see in a branch office? Like typically, is it usually 1 to 2 Mbps, or is there a lot of variation there?
I'm not sure I understood what.
So in the branch offices, typically, do you see this type of bandwidth available, like 1 to 30 feet?
Yeah, yeah. And you know, we arrive to with branch repeater, we have an average of 20 kilobit per second per user. Okay, an average. Okay, and they are also using Internet Explorer. They have a Flash application and so on, and it works well. To be honest, the thin client are Windows 7 embedded clients. It's very important to have that, to have enough power on the client side. Okay, for the HDX redirection. So, conclusion. Citrix Branch Repeater is the only one accelerator able to go deep inside the ICA protocol, the ICA, not for the other protocols we saw. However, I say that now because Cisco is not officially released, but I don't know if I have to add WAN, the only one, okay? Because of the WAS, Cisco WAS availability, okay? However, there are some differences about multistream, for example, about QoS also, as I told you, because Cisco optimize only TCP, have TCP optimization and indexation, deduplication, compression optimization, okay? But, so I think it will really interesting. I had a lot of discussion with Sean Bass, Benny Rich, and so on, and you know, they make a wonderful presentation about remote protocols. And for Sean, for example, it's completely stupid from Citrix to sign this agreement with ICA, because Citrix thought that he will be anyway the only one able to optimize ICA, but to be honest, it's not true. I think Cisco WAS will be really interesting because you have already, I'm sure, a Cisco architecture, and I think it will be difficult sometimes for Citrix to compete against Cisco. So, Riverbed is really good, really good. I have used it, it works well, but the main issue is the fact that it's not supported by Citrix. And we don't know if Citrix change anything in the protocol. It can be very difficult to Riverbed to do the reverse engineering again, because all the work of Riverbed is based on reverse engineering. So that's very important to know that. So if there is any change in the ICA architecture, Riverbed needs a lot of time to implement it in his new Riverbed OS. Regarding Silverpeak and Bluecoat, okay, they have some benefits regarding TCP optimization, for example, but so it's really simple. So if you have such solution, of course, you will not change to another one, but to decide to go to Silverpeak and Bluecoat if you have a lot of desktop virtualization, I think it's not a good idea. So, a last sign of the road. Any question? We have about 5 minutes.
From your experience using Citrix, Zendesk, one Zendesk, how much bandwidth does average user use? Using obviously your WAN Acceleration.
Yeah, so as I told you, I don't like to give numbers, but so the number 100, okay, can be good for first estimation, okay? And what I saw is that with Branch Repeater, you can go to 20, okay? So that is the same as before. So it's really interesting, okay? But I don't like to use that.
One here. We've got one in the back here.
Oh, sorry.
Hi, the multi-streaming support that you mentioned, is that something new to the branch repeater, or has it always been in the product since Orbital Data?
No, it's pretty new, and it's only available on the Linux appliance. It's not yet available for the Windows. You know, it's not yet released. They announce it, but it's always postponed. But it's just the ability to manage it. Because, for example, with Cisco, they say they don't support it, but they say you don't have to activate it because you are not able to manage it. So it's just the fact that you can manage 4 different TCP flows.
How about
Just
the?
that.
I was also curious about the, the complexity of setting each device up. Which one did you find the most difficult?
To implement, you mean? So I think Riverbed is very simple to use. I really like Riverbed for the simplicity. Branch Repeater, it's okay. So you have to have an expert. So the main architecture issues is where to place the WAN accelerators. Directly, so what we call, physical inline or virtual inline. And when you put it physically, it's really easy in this case, but you cannot manage very well the high availability. If you want to manage high availability, you have to go in virtual inline, and then you have to manage protocol like WCCP and so on, and then it's really difficult to manage high availability. So I think for me, without high availability, it's easy, but it's almost impossible. So with availability, it's not so easy with Branch Repeater. It's easier with Riverbed. Yeah.
A question about the overall user experience. Some organizations will have users go to a centralized data center to access Citrix, but their user data or their unstructured personal data is on a regional satellite office, and that creates challenges for optimization where you have people actually going to a data center, yet they're physically somewhere else, and there's a lot of cross traffic. So I know I'm kind of going off just ICA solely, but for the appliances that you reviewed, which ones happen to address the overall need to compress and cache to optimize the user experience for those that aren't ideally suited to accessing all of their data in one location?
Yeah. So it ended up Riverbed. Riverbed for data, for file, SciFS, and so on is really wonderful. Their deduplication and indexation algorithm is really good. However, for what you are saying, I think the best way is to centralize also the data. I know it's very difficult, it's a challenge, but I think you have to do it. Okay. So, but if you can't, then I think it's Riverbed is really, really good.
All right, we have time for one more quick one. Here.
So you mentioned that PCoIP says that you don't really need the WAN accelerators with that.
I didn't say that.
Okay, sorry, I misunderstood then.
No, VMware.
Okay, I
says,
see. Okay.
Not me. For me, he needs, but we cannot.
So what has been your observation when you look at use of PCoIP for branch offices, and when you compare it to ICA, like what's your observation there in terms of performance?
So I have one example in banking. I have one of my biggest customer is BNPP, so the French bank. And one of the subsidiary tried to use View with PC over IP from a subsidiary, a branch office in India to the data center in France, and it's simply impossible. It doesn't work. And they tried with PC over, with Riverbed, but to be honest, I don't know why they tried, because it was impossible that it works. So it didn't work, of course. And now they are moving to Xen Desktop and HDX because of the latency issues.